Hi, today I'm going to talk about addressing modes in 8086. Before even starting to discuss about addressing modes in 8086, let's also understand what is instructions and how it gets executed in a microprocessor. Okay, so when we start our instruction cycle execution, we generally refer to this terminologies of fetch, decode, and execute. Sometimes indirectly, we also have to point about what is store operation basically, right? Fetch is all about getting the data from the memory or from the IOs, input output units, and decode is all about understanding the instructions and then executing on this to processor and indirectly to point about when an operation is completed, the data has to be stored in the memory. Okay, so when we get this execute process, we stop it over here. So what actually happens is that mission instructions gets generated. Okay, so this cycle is going to run finally to get the final mission instructions generated out of this assembly instructions that we write. Right. This process will be interrupted only when there is an interrupt getting generated. We refer to this particular concept of uh, interrupt, and if there is an interrupt, this particular interrupt routine will get serviced. In other case, the cycle keeps repeating, right? So to mention about this instruction format, we have this particular structure where we have an opcode and operand, and there is also something referred as addressing modes over here. Okay. Uh, Before venturing into addressing mode, we'll understand about what is opcode and what is operand. Opcode, also referred as operational code, and indirectly we would point this as mnemonics also. Okay, operational codes is all about what kind of execution is going to happen. An operand is all about the real data that we wanted to work in, whether the data may be an immediate data, or it may be the data may be stored in a memory, or the data may be stored in a registers basically. Okay, so here if we wanted to connect this fetch, decode, and execute into this particular instruction. So the fetch is all about getting the data, or getting what is this operands all about. Okay, and the operational code is all about decoding what kind of instructions is going to be executed here. And the addressing mode is going to refer to whether I'm going to work with a direct addressing mode or indirect addressing modes. So we can also refer this particular concept of fetch, decode, and execute as pipelines, right? So let's uh, understand this particular high-level language to machine generated instructions actually. So what happens literally is that whenever we write a assembly program, this assembly program actually gets translated to machine level instructions. Whether we write a C program or we write an Python program, irrespective of any kind of a high level language, actually what happens is that the high level program gets converted to an assembly language program through an assembler, and then this from this we generate the machine instructions, and this particular machine instructions is actually getting executed in this process. This is the stages of creating the binary instructions that is going to be executed processor. Okay, how actually an instruction gets executed in a processor is that, let's say we have this program as pointed out here, move an addition program here. Let's go through this particular assembly program step by step. Move AX 4567H, the immediate data that I am moving over here, gets updated in the accumulator. And the second instruction, MOV BX 2222, gets loaded onto the BX accumulator. And then there is an addition operation that's going to happen here. This addition is going to executed in this particular ALU unit. So this particular ALU unit is executing this particular add operation, and then that is reflected in the accumulator. And then finally, I wanted to save this particular data from accumulator to a memory. So what happens is that this particular accumulated data is moved to an address location 2000 as pointed out here. So this is treated as an address location. To this particular address location, the 6789 is moved as a data and stored over there in memory. Okay. So this is the real reflection of how the instructions are executed in the microprocessor. Basically. So based on this particular process, there are several kinds of way of addressing this particular, which we call it as an addressing modes in 8086. This can be broadly classified by sequential control flow instructions and control transfer instructions. So first one, sequential control flow instructions is all about uh, the control of instructions is moving one line. I mean, it jumps to the next instructions immediately without validating any kind of controls. Okay. Okay. In today's session, we'll focus only on sequential control flow instructions. And here we have 8 types of addressing modes here. Uh, it depends on whether I'm moving a data from a memory location, whether I'm moving a data between registers, whether I'm moving an immediate data, basically. So let's try one here. First, mentioning about register addressing mode. Here, all the data is actually held in register. Basically, the data is moving between registers actually here. Any kind of registers maybe. Okay. And the best part here is that registers is the fastest execution unit in a processor. And all the operands is actually held in registers. So which means it's the fastest execution uh, unit instructions basically. And the limitations is that we have only limited number of registers that we are going to operating on here, right? MOV AX, BX is a classical example of this register addressing mode here. As you can see, we are moving a data between these successive. Okay, next, the addressing mode is immediate addressing mode. Here, we would be moving an immediate data to a register or even to a memory location here. Okay, so the one of the operand has to be a register, and the other would be an immediate data that we are pointing out. It can be an addition instruction or arithmetic instruction. It can be a move instruction. Okay. Again, the best part here is that there is no memory fetch operation that we are going to do over here. So which means that it is again one of the fastest execution instructions here. But of course comes with the cost of a limited range of instructions that we can operate on for moving a immediate data that we can operate on here. Okay, so as you can see over here, let's assume we have an accumulator value to be 0. We are going to execute an addition instruction. So the accumulator gets updated with the operation that we are doing on here. Next, the direct addressing mode, which is all about moving uh, a data from a memory location to the accumulator here. Okay. For example, add AL comma. When we point anything within the square bracket, it is referred as a memory location here. Okay. Let's assume this 1234 is holding 45, which is the data, 8-bit data. Okay. And AL is going to be having 0. And then what happens outcome of this particular instruction is that accumulator, the lower bit will get updated with 45. Whatever that was there with the AH register will be retained as it is. Now, there are several kind of addressing mode which is going to work with segments, memory segmentation. So let's understand in little detail about these kind of addressing modes. Okay. First one, the register indirect addressing mode. So, as the name indicates, the register is holding an offset value, and this offset value is taken to the address calculation, effective address calculation. Okay. So, first one here, um, each of these instructions specifies a register containing an address, and where the from the register we calculate the offset address, and from where we calculate the data. Okay, first one, move AX comma within the square bracket I mentioned about BX. So this BX is actually going to hold the offset value. Let's consider in this case the offset value is 50. Okay, BX is going to hold the data 50, which is the offset value. So what happens is this particular offset value is taken for effective address calculation. So so this gets updated as 50 plus whatever the actual data segment value. Let's assume the data segment value is 300. So the regular segmentation concept of works over here. 300 into 10H. It is the actual left shifting by 4 bits in binary. So 3000 plus the offset value 50 is taken for effective address calculation. So what happens finally is that 3050 memory location is being pointed out here, and whatever the data that was referred over here gets moved to this particular accumulator value as pointed out here. Okay, so the next one, the indexed addressing mode. Here this indexed addressing mode, here the offset address that I'm going to refer to is actually pointed in the indexed registers here. Okay, so takes this particular example, move AX comma within square bracket DI. So remember, anything that is mentioned within the square bracket is taken as a address location. So whatever the data that DI register is holding is calculated as an offset value from the base, from the segment, the respective segment that we are operating on. So in this particular case, what happens is that DI would be pointing to the offset address as 50. So this 50 is taken to the offset address calculation here. So executing this particular instruction, what would ideally happen is that 3000 plus 50 would be taken for address calculation, and whatever the data that was present over here is updated with the accumulator content over here. The next one, the register relative addressing mode. Okay, so the instruction specifies the register which is containing the address and where the actual data is going to be pointable. Okay, let's take this particular example, move AX comma 50H within square bracket BX. Please understand the second operand is containing two components. One is an, let's assume it is a data, and the other one is the register. But actually both are addresses. So the first one is also the offset address. The second one is also considered as an offset address over here. So what actually happens here is that this BX is going to get this particular offset address as 50, which is the actual data which was already residing there. So what happens here is that the effective address is calculated as 50H, which is this particular 50H, and the second one, the data segment is multiplied with the 10H, and then the BX, which was holding this 50, is also replaced with this value 50. So what happens, the effective address calculation in this particular case is that uh, the 50 plus 3000 plus 50 is taken for effective address calculation. So the effective address is going to be 3100, and whatever the data, let's say in this particular case to be 10, gets updated to the accumulator. Please understand, it should not be 3050 that usually students will make over here. Okay, so it has to be 3100, so that gets updated to the accumulator here. Next one is all about based indexed addressing mode here. Okay, again, kind of similar concept here, except that we don't have this immediate data that we are going to operate on. It would be two registers that is going to hold this particular offset value. Please understand, the second operand is going to have two different components, and both are going to be registers. One is pointed without bracket and one is pointed with bracket, but both are going to hold the offset value for the effective address calculations here. So actually what happens here is that let's interpret as BX is holding the data 10 and DA is holding the data 50. But actually both are calculated, effectively providing the offset address to be calculated actually. So what happens is the data segment multiplied with 10 plus the content of BX register, which is 10, plus the content of DA register, which is holding 50. So we need to calculate the effective address by this particular way. So which is going to be 3000 plus 10 plus 50, which is going to be 3060. So whatever the content, this particular memory location 3060 is pointing out is taken, and that is going to be saved to the accumulator here. Okay. So the final relative based index addressing mode. Um, See this example, move AX, comma 50H within square bracket BX within square bracket DA. We have two registers, we have an immediate data, but actually all the three components are going to point to the offset address calculation, okay, which is the effective address calculation that we do over here. Okay, so previously we saw one or two components. Now we have three different components in the second operand. Okay, so how this effective address calculation is done over here is that, let's presume that BX is holding the data 10 and DA is holding the data 50. So what happens is that the effective address calculation takes 3000 plus 10 plus 15 di plus 50, which is referred by this particular 50H that we have mentioned over here, which is referred as a relative based indexed addressing mode. Okay, so the effective address out of this particular calculation is going to be 3110, and the data that we have over here will be updated to this particular accumulator value over here. Okay, so if I have to run through all the three different uh, ways, is that we may have an immediate memory from where we are going to move the data. We may have the register pointing to the memory location, and then we may have combinations of memory and registers pointed over here, and then based on that we need to do an effective address calculation. And one important point to note that here is that the operand may be present at any places over here. It may be move 50H, comma within square bracket BX within square bracket DA, comma AX. So the this one can be the first operand, AX can be the second operand. It doesn't matter over here. Okay, the doesn't matter. We'll have to put this into the second operand only. It can be even in the first operand, but one of the operand has to be a register. where we are going to operate on. The other operand can be, however, depending on the addressing mode that we are going to operate on. Okay. I hope this introduced to the 8 different addressing modes on the sequential control flow instructions. Thank you.